Everybody, just helping out with the 2.2 graphs assessment. As a reminder of what we're doing with the 2.2 graphs assessment is we are trying to find the functions for curves that have been given to us. So here we're just doing a little bit of practice. We've been clearly given some curves and we are trying to find out what the function is to them. We're going to start out with the red curve. What we're doing when we're looking for the functions is first we need to identify the type of function that they're using. So here I can see from the gradient of this curve that it is very shallow to start off with, and all of a sudden it skyrockets up. When we see this type of shape, what we're looking at is an exponential curve. Now in the assessment, you're going to be given all of your base formula. So you'd be able to look at your cheat sheet and see that the base equation for this is going to be y equals a to the power of x plus or minus b plus or minus c. I'm just going to change this real quickly so it looks more like an x. Yeah, so we've got our base equation, and then the other thing that we need to identify are our features. First one we need to identify is our asymptote. So I've got my asymptote that's running along here, and I'm actually going to make note of that in writing as well. Asymptote is at y equals -4. And then we also want to find that 0, 1 point, that point that the curve crosses one higher than the asymptote. And in this case, we're going to find it right here. Yeah. So that 0, 1 point, we're going to say is at over 3 down 3, the coordinate 3, -3. Okay, so we've got most of the information that we're going to need to figure out what the function is for that exponential curve. Okay, now we're going to go ahead and look at the blue graph. I'm going to erase some of these marks that I made here. Now, as we're looking at this blue curve, we can see that there are two different lines that are created, and both of them have an asymptote, right? We've got an asymptote here, a horizontal asymptote, where this blue curve is never touching it, and also this blue curve on the left is never touching it, right? It's never going to connect. We also have a vertical asymptote. Got this one right here. So in this case, if we have two different asymptotes, one vertical and one horizontal, we know we are working with a rectangular hyperbola. Oh no, I'm going to run out of room. We'll just call it a rectangular hyper. Yeah, we've got a rectangular hyperbola. Our base equation for a rectangular hyperbola is y equals a over x plus or minus b, all plus or minus c. And I'm just going to make this line a little clearer. Yeah, and then we have to look at the features. Now the features we've already identified. We've got two asymptotes. Our asymptotes are we've got y is equal to +4 and x is equal to, what do we got? 2. And then we've got this point right here that we've identified right in the middle. Now the final thing that we need to do is we need to have another point in each of these graphs. We found those kind of starting points that we can use to guide our base equation. But we also need a point where those two things intersect. So I'm going to use my purple right here, and I'm going to give you a second to look at those two curves and see where they intersect. Remembering, intersecting means where they come together. Yeah, so in this case, they're going to come together right here. Our intersection point is going to be, let's see, over 5, up 5. So highlighting the little bits of information that we need now, we have our 0, 1 point where we've moved our 0, 1 point to, and we've got the asymptotes, and we've got our intersection points. So that's the information that we're going to use in the next part of working this out. Now that we've got all the information from our graphs, we're going to have to work out what our actual equations are. So I've just copied over the information that we collected, and we're going to have to think about this a little bit, okay? So if we've got our 0, 1 point has moved to our 3, -3 point. What has actually happened? Okay. Well, we had a point on a graph that was at over 0, up 1, right? Over 0, up 1. And then it moved to over 3, down 3. So what was the actual shift that happened from one to the other? What was the actual shift that happened from one to the other? Well, in this case, we went over 3. Yeah, we went from 0 to 3. So we went horizontal. We went 3 to the right. Okay, and then our vertical, we've gone from 1 down to -3. So our vertical, we've actually shifted -4. I guess I could make this a down instead. We've gone down 4. Yeah, so we're going to use that to substitute into our exponential formula. So let's get rid of this junk here again. Now that we've got that, what I'm going to do is I'm going to go y equals a to the power of x, and we want to have a horizontal shift of 3. We want to have a horizontal shift of 3, and in this case, it's going to be -3 because the horizontal shift always works in the opposite way that we think it should. If we're going right, we're going to subtract, and if we're going left, we're going to add. Yeah, so that's what we've done here. Now, to substitute in the vertical shift, we're going to subtract 4. Yeah, so now we've worked out our formula for the red graph, with the exception of course, our a value. We're going to work on that in a second. Yeah, next thing we're going to look at is our blue graph. This is going to be a little bit simpler because we're not moving, oops, that's red instead of black. We're not moving from the 0, 1 point like we were before. We're moving from the 0, 0 point. And what do we have to do to get from 0, 0 to 4? Well, we have to shift to the right 2 and up 4. So our horizontal is going to be right 2, and our vertical is going to be up 4. Nice, we've got that information all covered off, so we can use that in our formula. Y is equal to, I'm going to actually move this up a little bit. Y is equal to A over X minus 2. Remember, it works in the opposite way that we expect it to. I'll put it in red. Minus 2. And then we're going to have up plus 4. Brilliant. Now we've got our equations. We've got everything that we're working on except for our a values here, right? We don't have our a values. And the way that we're going to do that is we're going to substitute in our intersection points and then solve for a. Substitute in our intersection points and then solve for a. We have one intersection point that we're using for both of these graphs. Okay, and we're going to substitute that in, and we're going to find out what the a value for each of them is. Okay, so looking at this graph, our intersection point is at 5, 5. I am going to look at 5, 5 here. I'm going to substitute in the y portion of my value. The y portion of my value is going to be 5 equals a to the power of the x portion of my thing here, 5 minus 3 minus 4. And then all I have to do is solve for that. Okay? So I'm going to add 4 to both sides. That's, oh, I should do BEDMAS. I shouldn't add 4 both sides. I should start with my bracket. So I'm going to have 5 equals a to the power of 5 minus 3 is 2 minus 4. Add 4 to both sides is 9 is equal to a squared. And then I'm going to take the square root of each. And I'm going to find a is equal to 3. So the final formula that we've got for our excuse me, exponential curve is y equals our a value 3x minus 3 minus 4. That is our final equation that we're using for this exponential graph. What about our rectangular hyperbola? Well, we're going to do exactly the same thing. I'm going to substitute in my 5 into my y value equals a over, and then I'm going to substitute in my 5 for my x value minus 2 plus 4, and then all I have to do is work this out. So 5 is equal to a over 3 plus 4. 4 is subtracted from both sides. 1 equals a over 3, and multiply both sides by 3. 3 equals a, or, of course, a equals 3. And so my final equation for this is going to be y equals 3 over x minus 2 plus 4. Exactly the same thing again, but this time for different curves, yeah? So function type, this red graph, we can see pretty quickly that it's a hyperbola or parabola, quadratic equation, yeah, so we're going to say hyperbola here, the formula, y equals, open bracket, x plus, or, oh, I've missed one, sorry, a, open bracket, x plus or minus b squared plus or minus c, and the features, the big feature on a hyperbola is the turning point, which is right here. So our turning point is going to be, our turning point is going to be -2, -1. Okay, and then the blue graph, our function type, that is a cubic. Our formula is y equals a x plus or minus b cubed plus or minus c. And our features, again, this is going to be our center point is going to be at, what is that, over 5 down 2, 5 minus 2. And our intersection, the point where both of them cross, is going to be over 1 minus 4. And that's all the information that we need. We can take that on to the next slide. We've got the same thing again, right? We've got our function types and our formulas already worked out. We've got our turning point and center point. So all we have to do is substitute in our values. Okay? So y equals a open bracket x. I'm shifting it to the right 2, so I'm going to subtract 2 for b. Yeah, so minus 2 all squared minus 1. So I have now used these 2 points and substituted them in for b and c. Same thing with my other graph. I have y equals a x. Here I'm shifting to the right 5, so I'm adding 5. Oh, excuse me, so I am subtracting 5. Yeah, so minus 5 cubed minus 2. We now have created that equation with the substitution from the center point and the turning point. Now we're going to use the intersection point to substitute into them both, right? And here, oops, pen, orange, here I have my x value and here I have my y value. So I'm going to substitute those in accordingly up in both of my equations. Okay, so my y value is -4. -4 equals a, open bracket, my x value is 1, minus 2 squared minus 1. Doing BEDMAS, I'm going to work out what's in the brackets for first. Minus 4a minus 2. Oops, not minus 2, silly man. Minus 1 squared minus 1. -3 is equal to a, open bracket, -1 squared. -3 is equal to a times 1. -3 is equal to a. Yeah, so my base equation for this side is going to be y equals -3 x minus 2, close bracket, squared minus 1. Gorgeous. Now we can do the other side, exactly the same thing. I'm substituting in my y value first. Negative 4 is equal to a, open bracket, and then my x value is 1 minus 5 cubed minus 2. Minus 4 is equal to a times negative 4 cubed minus 2. And I'm going to add 2 to both sides. Minus 2 is equal to a. Now, if you're going to put this in your calculator, be really careful that you have to include your brackets in here, right? Because this is negative 4 times negative 4 times negative 4, which is the same as negative 64, right? So get rid of this working, and we're going to put it in here, negative 64, okay? And then we're going to divide both sides by negative 64. Negative 2 over negative 64 is equal to a, and therefore a is equal to 1 over 32. So my full equation is going to be y equals 1 over 32 times x minus 5 cubed minus 2. And now I have both of my equations. Do this one final time. We have two different graphs here, the red and the blue graph. Looking at the red graph first, I know that this is going to be a square root graph. And I know that because I've got a starting point and it kind of does this weird sort of gradient that comes along here. So we've got a square root graph. The formula for that is y equals a times the square root of x plus or minus b plus or minus c. And the features, we've got a starting point. We've got our starting point at, where is it? Negative 3, positive 2. Yeah, and then for our blue graph, we know that's going to be a cubic. We're using exactly the same one that we used before, so that's going to be, oh, what's going on? Y equals a, open bracket, x plus or minus b, all cubed, plus or minus c. And our features, we've got our center point is at, where is that? Over 2 up to 2, 2. And finally, we need an intersection point. That intersection point is going to be right here. We've got over 6 minus 4. 6 minus 4. How good? Really quick now. Final calculations. We're getting pretty quick at this. We know exactly what's going on. Our starting point is shifting horizontally and vertically. So we are going to have y equals a square root of x plus 3 plus 2. And on this side, y equals a x minus 2 cubed plus 2. And now we're going to substitute in our intersection points. We've got x and y. So I'm substituting those in over here. Y is minus 4. Minus 4 equals a square root of, what did I say? 6 plus 3, all plus 2. And now I can do these calculations. First thing I'm going to do is what's inside the square root. 6 plus 3 is 9. Plus 2. Now I can do that square root itself. So the square root of 9 is 3. 3a plus 2 is equal to negative 4. Subtract 2 from both sides. Minus 6 equals 3a. And divide 3 both sides. Minus 6 divided by 3 equals a. A is equal to minus 2. So my equation for that, and I'll change my color, y equals negative 2 square root of x plus 3, all plus 2. Gorgeous. Now we got to do our other side. Same thing again. We're substituting in our x and y values. Minus 4 is equal to a. Oh, oops, I almost put x, and what I meant was 6 minus 2, all cubed, plus 2, doing what's inside the brackets. 6 minus 2 is 4 cubed plus 2, negative 4. 4 cubed is 64a plus 2. Subtract 2 from both sides. Negative 6 is equal to 64a. Negative 6 divided by 64 equals a, and therefore a equals negative 2 over 32. So my equation is y equals negative 2 over 32, all times x minus 2 cubed plus 2. So there we go. We figured out a few different equations here now. Y'all can go away and have, have a little bit more practice on the other thing that I've got there for you. Good luck. Hope it goes real well. Glad you stuck around with me. Take care.